Okay, so we're going to do question 6.16. So in this question, we are given a utility function as a function of b and c equal to b power half and c to the power half. Okay, so this is just a normal capital last product utility function. So it's asking you to find the marginal utility MUB and MUC and the marginal rate of substitution. Okay, so the marginal utility B is just going to be the differential of the utility function with respect to B. Okay, so this is the partial derivative where we differentiate a utility function of two variables B and C with respect to one variable B in this case. Okay, as we know from before, if we differentiate utility a function with respect to B, then we're treating C as constant. Okay, so therefore C to a power half is constant, it's just going to remain the same. And if we differentiate B to the power half, then using the power rule, we are going to get 0.5 B to the power 0.5 minus 1. Okay, and that will just give you 0.5 C 0.5 B negative 0.5. Okay, so very similar for marginal utility of C, which is just going to be a differential of utility function with respect to C, and therefore we are treating B as constant. So therefore B 0.5 is going to remain the same as a constant. And if we differentiate a function C to the power 0.5, applying the power rule, then we get 0.5 C to the power 0.5 minus 1, and that will just give us 0.5 B to power 0.5 C to power negative 0.5. Okay, so therefore the marginal rate of substitution is just going to be the negative of the marginal utility ratio, and so I get negative 0.5 C 0.5 B negative 5, so at negative 0.5, and divided by 0.5 B 0.5 C negative 0.5. Alright, so negative, now 0.5 cancel with 0.5 over here, so they cancel out, and I got C 0.5 remain the same over here. Now if I move C negative 0.5 from the denominator to the numerator, then I should be able to get rid of the negative sign. Okay, so it's become C 0.5. And very similarly, B 0.5 over here remain the same, and if I move this B to the power negative 0.5 to the denominator, then it will become positive. Okay. Alright, so here I get negative C power 0.5 plus 0.5. Now it's just basically the sum of the power rule, where you know that if you got so x to the power a times x to the power b, that would just be equal to x to the power a plus b. Okay, so that's the power rule. So we're applying that into this case over here. That will get us again similar B 0.5 plus 0.5, and so that's become C negative C on B. Alright, so that is our marginal rate of substitution. Okay, now part B, asking you for each of the following situations, obtain the relative price of the goods, find the income expansion path, and find the most preferred affordable consumption bundle. Okay, so the first case is where we have an income of 60, we have the price of good B being 2, and the price of good C being 3. Okay, so the relative price is just going to be PB on PC. Okay, now why are we having PB on PC instead of PC on PB? It doesn't matter. Okay, so if you want to use PC on PB, that is totally fine. However, it has to be consistent with the marginal rate of substitution that you are using over here. Okay, so if here you are using the ratio of marginal utility B on marginal utility C, then in the relative price it has to be PB on PC. Okay, so you can move it around. You can swap the ratio, it doesn't matter, but then you will have to swap the ratio for the marginal rate of substitution as well. Okay, so therefore it just has to be consistent between these two ratios. So if you got B first on the marginal rate of substitution, it has to be B first in the relative price, and vice versa. Okay, so if you got marginal utility of C on marginal utility of B, then the relative price, it has to be PC on PB. Okay, so in this case, because I choose MUB on MUC in my previous part, so therefore I will have to have PB on PC in my relative price, and that will just be equal to 2 on 3. Okay, now what is the income expansion path? It is basically just the line that is including all the most preferred affordable consumption bundles. Okay, so in order to find the income expansion path, we will have to find the equation for all of the most preferred affordable consumption bundle. Okay, so we know that the most preferred, or outside the optimal bundle, is the bundle at which marginal rate of substitution is going to be equal to the negative of the price ratio. Okay, negative of the relative price. So it's basically just the point, just the tangency between the slope of the indifferent curve. Okay, so we know that marginal rate of substitution is the slope of the indifferent curve, and the negative relative price is just basically the slope of the budget constraint. Okay, so where the budget constraint is tangent to the indifferent curve, that is the most preferred affordable consumption bundle for a well-behaved preference. Okay, which is the case here, where we have a Coq-Dolas product utility function. Okay, so our preference is well-behaved, and so therefore this is the condition for us to find the optimal most preferred affordable bundle. Alright, so knowing marginal rate of substitution from the previous part, which is negative C on B, and the relative price is just 2 on 3, so therefore I have C equal to 2 on 3 B. Okay, the two negative sign will just cancel out. Okay, so this is the income expansion path. Okay, so this is the equation for the income expansion path. So any bundles of B and C that satisfying this equation is going to be lying on the income expansion path. Okay, and the next part asking you to find the most preferred affordable consumption bundle. So now in order to find the consumption bundle B and C that is optimal, given this income and the prices, we just have to substitute this optimal condition over here into our budget constraint. Okay, so our budget constraint in this case would just be the price of good B times the amount good B, price of good C times the amount good C, and that has to be equal to income. Okay, so 2B plus 3C equal to 60 in this case. Alright, so if I substitute the C equal to 2 on 3B into, so this is my optimal condition, and into our budget constraint, then I will get 2B plus 3C, and C will just be equal to 2 on 3B. Okay, and that equal to 60. So I got 2B plus 2B equal to 60. So 4B equal to 60, and so therefore B equal to 15. Alright, so knowing the value of B, I should be able to find the value of C very straightforward, which is just equal to 2 on 3B. So 2 on 3 times 15, and that would be equal to 10. Alright, so the most preferred affordable consumption bundle, or it's just a simple way of calling it, is optimal bundle. In this case, is where B equal to 15 and C equal to 10. Okay, so the next part is going to be very similar. It's just that we have a different income and a different prices. However, everything else is just the same way of doing it. Okay, so again, the relative price it's just going to be PB on PC, and that is just going to be 6 on 7. Okay, so again, the optimal bundle is going to occur at the point where marginal rate of substitution equal to the negative price ratio. And so therefore negative C on B is equal to negative 6 on 7. And so C equal to 6 on 7B. Okay. Now substitute this condition into our budget constraint. And the budget constraint in this case is PB, which is 6 times B, plus PC, which is 7 times C, equal to 84. Okay, then we have 6B plus 7C, and C is just going to be 6 on 7B, and that is equal to 84. And so therefore I got 6B plus 6B equal to 84. So 12B equal to 84, and so therefore B equal to 7. Okay, so knowing the value of B, we should be able to find C straightforward, which is equal to 6 on 7B. So 6 on 7 times 7, and that will give us 6. Okay, so therefore the optimal or the most preferred affordable bundle in this case is where B equal to 7 and C equal to 6. Alright, so the last part is going to be very similar, so I'm not going to go through it, but you can use that as a practice. Just repeat what we already did in part A and B. It should be very straightforward.